Good morning to all the participants for attending this orientation and demo session today on a Saturday morning at 11 a.m. And a big thank you to all of you for taking your time and attending. Currently, I see 19 of you actually who have uh, present in the session. So before I start the session, certain things on the logistics of the session. Okay, the session will be for probably 1 hour or 1 hour 30 minutes, and the objective of today's session is to tell you what data science is all about, okay, and to answer some basic questions like what is the difference between data science and machine learning, what is AI, what is data science, what is business intelligence, how does big data and data science have a role together to play with, and what skills you need to have in order to be a data scientist, what kind of opportunities are present out there for a data scientist, and typically if you become a data scientist, what is your role and responsibilities in the organization, and what is the typical life cycle of a data science project. Okay, so I intend to cover all these aspects, and I believe after I cover all these aspects, all the audience who are present in this session will have much more better information and clarity on what data science is all about or machine learning is all about, and can take an informed decision on uh, joining a data science course or pursuing a career in data science. Okay, that is really the purpose of this session. And currently I do see 21 audience, and I know sometimes in an online session the number of attendees might spike up and spike down, and typically the batch which will start either in the regular or the advanced course will be of a maximum of 15 to 20 people. I think I prefer 15 people to be in the batch, and obviously after this session whoever wants to join and can communicate with the operations team, and we will start off a batch with 15 people. Okay, so I'll do one thing. I will actually talk about my introduction about myself. Okay, probably in the first 5 minutes, so that you understand what kind of a background I come from, and you can also aim your questions accordingly. As I'm introducing myself, I do see there are 19 or 20 of you guys over there. People, I suggest that type in the chat box. Okay, there is a chat box over here. There are 20 people over here, so I may not be able to be in a position to unmute all of you and take your introductions, because in the interest of time, and also sometimes it has been observed when we do that, right? There is a lot of delay in the way in what we are trying to present. So I suggest like all of you to actually give you an introduction in the chat box. Maybe tell us what you're doing, like which city you're from, and also what is your expectation from this session. Like you can even ask some of your questions, and what do you and what is your understanding of data science. Okay, the last part maybe some of you can leave it if you don't have any understanding what data science is all about, but definitely put in your expectation and where you're from. Okay, obviously there are some people who have already taken the liberty to give their introductions even before I said it. There is Abhishek who's from Lucknow, and there is Romi from IIT Roorkee, okay, and there's Bhaskar from Hyderabad. Why don't you guys keep in, and as I introduce myself, after my introduction I will introduce some of you guys, and it will be a lot good if you guys can give not just one line introduction saying that this is I'm here from this location. Also, if you can ask some questions, that will be great. Okay, that's the first thing. Second thing, what I want to make it out is in this 1 hour session, I want it to be as interactive as possible. And when I say as interactive as possible, I would like you guys to type in your questions in the chat box uh, as I'm actually presenting some of the important things. And I will make sure that I answer all your questions. In case I don't answer your questions at the instant when you type in the chat box, that's because I'm in my flow of my presentation. I will answer the question probably when I finish whatever I'm speaking, and address your question at the right moment, maybe after I finish some part of my speaking. So keep that in mind. So to introduce myself, okay, I'm Sravan Chaitanya, and I come from a engineering and a business background. I did my engineering from IIT Madras and my MBA from IIM Ahmedabad. and I have close to around complete work experience. If we talk about it, I have close to around 15 years of work experience. In this 15 years of work experience, a good amount of 11 to 12 years has been in the area of data science, call it AI or call it business analytics. And I've seen the space right from 2007 onwards in a variety of roles. I've seen the space as a developer, being someone who has actually coded and built data science solutions. I've seen the space as a project manager, and I've seen the space as an account executive who's handling a account where a data science project has been implemented. And I've also seen the space as a sales executive who has sold data science solutions. Currently, I'm an entrepreneur and I run a company called Spaikaven Info Solutions. And as a company, what we do, we are using AI, artificial intelligence or data science, you can call it, and blockchain to build solutions for the sales process, customer engagement process, and the customer retention process. Okay, that's what we do right now. And prior to this, obviously, I was part of a company called Cognitive Scale, which was an emerging startup in the AI ecosystem. They got funded by Norwest, Microsoft, Intel, and IBM. And I was employee number 5 over there, and I actually handled the entire delivery and to a large extent the product development in Cognitive Scale. And when I say product development, we did not build solutions which were just machine learning models which used to just give insights to the business users, but we actually build the end-to-end solutions, which includes a machine learning model, probably a UI, and probably the necessary back-end engineering, the necessary DevOps, everything. End-to-end is what we had experience in doing earlier. Okay, so we'll start the session. Before I start the session, I've seen that some of you have actually given your introductions, and I believe that this is an audience which is not so proactive because I only got introductions of hardly 6 or 7 people. Rest of the people, I don't know, in startup terminology, want to be in stealth mode because they don't want their identities to be known. Okay, so first we have, as I mentioned, Abhishek, who's from Lucknow. I don't know what Abhishek does, but he's joined us from Lucknow. Then we have Romi Agarwal, who has joined us from IIT Roorkee. I'm assuming that he's not in his winter break, but he's back to the campus and he's from IIT Roorkee. He's doing his BTech. Then we have Bhaskar Veeramalla, who claims who's from Hyderabad again. And then we have Vipin Chauhan in Noida with 10 years of experience. Then we have Megha, who is from Jammu all the way north, who is pursuing her MSc in economics from SMVDU. Okay. Then we have Ajay Mantri from Hyderabad. Again, I don't know about the background, but he says from Hyderabad. Then we have Harika, who is working as a senior clinical data coordinator, clinical data management. Welcome, Harika. And she wants to pursue data science, I suppose. And it could be a logical shift for someone who comes from a clinical data management or a clinical data coordinator kind of a background. And then we have Neha from Patna. She has 2 years of experience in the development sector. Okay, development sector is something which I don't have much of a details, but maybe you can add more details to it. Okay, Bhaskar is saying he's unable to hear me. All the audience, are you unable to hear me? If you can hear me, please type yes, na, because that's the only way I can know. And this, okay, they can hear. Bhaskar, probably it's a problem at your end. Why don't you just check up? Maybe you can log out and log in. And maybe the organizers, please talk to Bhaskar and see what you can do. Then we have Prabandha Biswal. He's from Bombay with 7 years experience. Obviously, it makes more sense if you guys can tell me what your experience is, but it's fine because I can talk about examples in this 1 hour session, maybe fine tune to some of your experience or examples from your industry. Then we have Sudhir, who's looking for practical training. I'm assuming Sudhir has some exposure to data science or machine learning already. So that's why he says he's looking for practical training. Then there is Niranjan Rao, who is a BTech from NIT-K. Okay, K, I'm not sure what it is, but I'm assuming it's Kozhikode, and he's in his 4th semester. So probably he's in his 2nd year. Welcome, Niranjan. I think it's early that you have joined this course, but nevertheless, an early bird catches the worm. Good. So then we have Prabhakaran, who is Chennai, and he's come from the healthcare background. And that's it. I think those are the people who gave the introductions. I will pause for another probably 30 seconds. Do anyone else want to give your introductions? Because I see there are close to about 20 attendees right now, but maybe the people who gave the introductions in the short and crisp way were hardly 8 or 9. Anyone else want to give the introductions? I'll just pause here for a minute. Okay, there is Praveen Rai, who's a software developer from Noida. Welcome, Praveen. And as software developers, okay, if you believe that this could be a natural progression, and I do believe it is a natural progression, I'll talk about that. Anyone else? Okay, good. So we'll start the session now. The time as per my clock is 11:10, and I intend to complete at least the session by 12:10 in 1 hour, but in case there might be a spillover for another 20 or 25 minutes, please be patient, and I suggest all 20 of you, whatever be your schedule, anyway you have joined this session over here, uh, be in the session till probably 12:10 to 12:30. That's where I will tentatively end the session, and you're taken out time to be part of it, so try to get maximum out of it by asking questions and also being attentive, and ask what you really are looking for. Okay. Ajay Mantri wants to add an additional detail to his things. He says, myself is an SAP Success Factors consultant, and he's based in Hyderabad. Welcome, Ajay. And in my past, actually, I have trained people who are SAP functional consultants in the area of data science, and these were all people who had more than 18 or 20 years of experience. People who are very senior, and unfortunately, I was fortunate to train those people on data science, and hopefully they found some use in data science. So hopefully something similar will happen with you as well. Thank you, guys. So let's start the session. Let me put in a slideshow mode, and okay, sometimes my system could be a bit slow, so just bear with me on that. Okay, once again, very big thank you for considering Prime Classes, and Prime Classes is a one-stop solution to learn AI, ML, okay, both the interrelated, blockchain, data analytics, and digital marketing solutions. And of course, they're coming up with other offerings as well in the area of big data, Python programming, Java programming as well. So thanks for taking out time and coming to the session. And I do think this is a good place for you guys to pick it up, because most of the faculty, all the faculty, in fact, at Prime, are people who are actually practitioners who have a full-time job, where they're actually building. If I can talk about AI and data science, all the faculty over here are people who are involved in the data science and AI in their day-to-day life, where they're either building companies, startups in that space, or they're part of a larger company who's actually working in the data science team. And so these are people who are not theoretical in nature, but very practical in the way they teach, and they will bring in their expertise from a practical perspective and tell you what it is. So I think it's a great place for you guys to learn, but that's up to you guys to decide post this session and whenever you want to do it. Okay. So objective of any data science course being taught at Prime. Okay. First and foremost, the course will provide you insights about the role of a data scientist, and I think at least the first bullet point we should be able to complete in this session, because this entire orientation session is meant to give you insights about the role of a data scientist. Second thing, as part of this course, okay, data science, AI are the fancy words when you want to probably build the next generation thinking machines. That's what you might want to look at it. But the more fundamental thing is, how do you analyze data, right? So we will give you all the techniques, all the frameworks, and all the popular tell you about the algorithms which help you to analyze data, what you need to really look at, what kind of questions to ask when you analyze data. That's something which I'm sure you will become an expert at after you finish this course. Then third, you will definitely learn tools and techniques for transformation of data. See, data science, if you talk about it, data science or the role typically, if you look at the job descriptions out there in the market, okay, there are it's either the role is called a data scientist, sometimes it's called a data engineer, okay, and sometimes some fancy companies also have really fancy designations like cognitive engineer, right? But essentially, according to me, they're talking one and the same. And if you look at as a role as a data scientist, What I would like you guys to understand, there are two important words over here. One is data, another is scientist. The moment scientist comes into your mind, I'm sure all of us think of research. Okay, the scientist is someone who's supposed to be good at research, right? So you as a data scientist need to be good at research. Okay, when I say research, I'm not saying like you guys will go and start inventing something, or you guys will start doing some research in mathematics or something fundamental like that. But whenever you are presented with a problem, and the problem is going to be a business problem, you should go and research and find out about the domain of that business. Okay, what is that business all about? Okay, what are the factors which actually affect the business? Okay, you need to really understand that. Second amount of research could be like, hey, these are the factors which affect the business, and I believe that there is an insight which I can generate, which can improve this business in this manner. And to improve this business in this manner, I need to know what is the data which I can use, right? And most likely in the recent times, right, as a data scientist, you are a data scientist when you can extend the organization's data, okay, or your business data, which is internal to the organization. When I say internal to the organization, many companies have data which is generated by their ERP systems, okay, like SAP generates a lot of data. Many companies have data which is generated by the CRM systems, customer retention management systems. Many companies have data which is generated by the business process systems. Okay. First and foremost, you should know how to generate insights with that data. Okay. Second and foremost, you should have the ability to extend that internal data with third-party external data. Okay. To give an example, okay, I actually was part of a very interesting project which we did for the US healthcare industry. And US healthcare industry, there are bodies known as accountable care organizations, which are responsible for maintaining the population, the health of a population, especially a population which is affected by chronic diseases such as diabetes, asthma, blood pressure, and so on. And as you all of us are aware, these are lifestyle diseases. They cannot be cured, they can be controlled. Okay, and in US, typically if a patient ends up in an emergency room, his entire bill is paid by the insurance company and indirectly by the government. So people do not want the patient to end up in an emergency room kind of a situation, because that will actually increase the healthcare expenditure of the insurance companies and also the government indirectly. So in such a scenario, we came up with an intelligent alert system where we were capturing data on patients on several parameters. It was not just the health parameters like what is their blood glucose level. It's not just the health parameters like what was the blood pressure when they came last. We were also capturing data which was third-party data, and we did it for asthma. And as you guys all know, asthma patients are, they are very much prone to air quality or the pollutants in the air. They might have an asthma attack. So we were extending this internal health data of the organization and with third-party pollutant data. So that's what you're required to do as a data scientist. Extend the organization data with the third-party data. Okay. This was in the example of a healthcare industry where we needed to understand that, hey, asthma patients get affected by the air quality which is there. That is a domain understanding which we need to have. Number one. Second thing is, okay, we know that health of asthma patients affected by air quality. Can we bring in that factor in a model which predicts whether a patient is going to end up in an emergency room situation or not? Can we bring in that as a factor? So in case you want to bring in that as a factor, you need to have data on that, right? So now, is there data available? Yes, there is data available. How will you combine that data with your internal data? Okay, your internal monthly regular health parameter data. How will you combine the data? That's another thing which you need to do as a data scientist. So these are all techniques and tools. Some of these techniques and tools are probably come from the software domain, which are very easy to understand. You can pick it up. Some of these come from the knowledge of the problem which you're trying to solve. Okay. In this case, the healthcare example, the problem which we were trying to solve is the organization which was responsible for managing the health of these chronic disease patients. It was run by typically nurses who are very at a senior level, maybe who are 45 or 50 plus in age, and they were managing the population health. And these nurses needed to be given an intelligent alert system because each nurse was given the responsibility of close to around 1,000 patients. So it's humanly impossible for her to look at the health parameters of all the 1,000 patients when on any particular day. So can we give her an intelligent alert system which tells the nurse which patient to call, okay, which patient to actually fix up an appointment with the doctor, with which patient should she intervene, okay, that was all the purpose of this. So we need to understand the job of the person who actually is going to use this model. We need to understand the industry, we need to understand the disease, and then we needed to understand what is the third party data which is required for all this, even before we actually build out any particular solution. So all these things come under tools and techniques to transform data and do something over there. Okay. Okay, Manasa is unable to hear my voice. Are the others not able to hear my voice? Okay, Niranjan said it's clear. So Manasa, please, must be an internet connectivity issue at your end. So log out and log back in, and I ask the organizer team to actually check with Manasa and see what can be done with her. Yeah, with her system, you can just guide her on the phone. Okay. Next, going forward, okay, as a data scientist, you need to know machine learning algorithms, and we will teach you machine learning algorithms, and that's definitely part and parcel of this course. And so we'll help you to do that. And last and foremost, data visualization. Okay, this is a very important skill set which you need to have as a data scientist. Many times ignored by people, at least whenever you guys go out in the market or you try to research on your own. I'm sure all the material to learn data science is out there in the internet. Okay, if you do some smart Googling, you will get a lot of videos, a lot of presentation material which you can read or see and learn on your own. But what all these videos miss is they talk about the fancy stuff, predominantly the machine learning algorithm techniques, but they miss something which is as simple as data visualization. And data visualization is going to help you in analyzing the data before you actually think of what insights to present. Data visualization helps you to give you information what kind of machine learning model you can build. Data visualization helps you to understand, like, the machine learning model which I have built, is it the best or the most appropriate model? Okay, and data visualization also helps you to present your insights so that the business users are convinced with what you present. So data visualization plays a key role, and we will talk about it. Okay, and Megha, in the meantime, she's having a question. We do have to write codes of each and every problem. Yes, we will. This course will be actually, we will give you exercises, and you will have to code. And but keep in mind, data science is not just all about coding. And some things I want to write over here as an right now, so that to explain this. So there will be, you will have to write code, and we will share with you code for many problems over here, and that should help you to develop your coding skills as well. And let me write something over here. And guys, my writing may not be that great because, but I'll read out whatever I'm writing so that you guys can understand. If anyone doesn't understand my writing, please do ask me to repeat or explain what I've written. So just let me write now. So if you look at it, I want to draw a set diagram here, and let us call this set as data science. I'm going to denote this as data science, right? And for me, data science is synonymous to AI. I'll talk about that a little bit more in detail. Give me a minute. But what are the skills which you need to develop to be a data scientist? Okay, and these are, I will say, like, for lack of words, I'm using the word domain, but domain is not the right word. These are skills which are grouped under different areas. Okay, what are the areas under which you need to develop skill sets? Let's call them areas. So first area which you need to develop skill sets are data acquisition. Okay, since I don't want to write it completely, I'm using the abbreviation DA, data acquisition. And data acquisition is all about pulling data from not just structured databases like SQL, even unstructured databases, maybe even a big data ecosystem, or even a semi-structured database, semi-structured data. When I say semi-structured data, this is data coming from APIs, right? If any of you do not understand APIs, do ask me. And API is nothing but a protocol of exchanging data on the internet, right? It's called a REST APIs. So we exchange data in the form of XML or JSON. So any XML or JSON data is known as semi-structured data because there is some structure to it. And structured data is data which is coming in tables, okay, which could be your SQL data, or it could be even data in Excel sheets. That's structured data. And we also have unstructured data. Unstructured data is either text and images or videos, or even log files which are in a particular format. So you should be in a position to acquire this data from multiple sources, and you should know how to combine this data and process this data. So I do believe as a data scientist, you need to pick up data pre-processing skills. Okay. So when I talk about data pre-processing skills, of course, you need to understand how to extract, transform, load data. Okay, but we won't go into details of those kind of data pre-processing. We will talk more about from a statistical perspective. How do you pre-process data? Like if there are some records which are missing, okay, because how do you fill in missing values? Okay, if there are extreme values are known as outliers. Okay, obviously we won't get into the definition of outliers in detail in this session. We will get into it later. But extreme values, like for example, you are trying to analyze banking data to give personal loans, and you know your loan product, your personal loan, you give it to people who are having a monthly income of probably 25,000 to probably 4 or 5 lakhs in a month. Okay, and there you do have some people who have incomes of probably 1 crore or 2 crore CR in terms of the monthly income. So they have extremely high values in income. So they're outliers. So how do you remove them? That's also data comes under data pre-processing. And also part of data pre-processing is what I've mentioned earlier. You have data from multiple sources, not just your internal source from the company, but you have data from external sources as well. So how do you combine all this data? So that is also data pre-processing. So, okay, and we have someone who has a late entrant here, Mr. Rajshekhar, who says he's a VMware engineer and 8 years of experience, and he wants to understand if he can take up data science. Rajshekhar, welcome, and hopefully my session will tell you what you need to have in you to be a data scientist. Okay, so going back to my presentation, so data acquisition skills you need data pre-processing skills. Okay, you need some data analysis skills. Okay, data analysis, I'm just saying DAN because I don't want to write the entire thing. Data analysis. So this is like basic analysis of data through visual means and also non-visual means, but obviously a good amount of data analysis happens through visualization, data visualization, but some amount of data analysis also happens through non-visualization. It could be like finding out summary statistics, like something as mean, median, mode, basic stuff which probably you guys are aware about it. Doing some basic hypothesis testing on the data, right? And of course, as I mentioned, you need to know data visualization. I'm just drawing this a bit bigger because data visualization DV, okay, part of data visualization goes in data analysis. But as I mentioned, data visualization will also help you to understand what kind of machine learning model to build. It will also help you to understand evaluate the performance or the output of a machine learning model, all that, and it will also help you to present your findings as insights to the business user. So data visualization is a key skill set. And apart from data visualization, okay, a very big box which we will cover, in fact 60 to 70% or 70% of a course is machine learning. Okay, I'll call this ML. Probably that is what is the popular terminology. Machine learning. And machine learning, we will cover all the popular algorithms. Okay, to just name a few: logistic, linear, support vector machines, neural networks, naive Bayes, time series, whatever. We'll cover all of these, and I'll tell you what machine learning is all about. So machine learning keep in mind, is a subset of data science, okay? But it's a huge subset because, really speaking, as a business analyst, you may do some amount of data acquisition, you may do some amount of data pre-processing, you may do some data visualization, and you may present insights which are like a post-mortem analysis. Am I right? As a business analyst, you do present insights which are more like a post-mortem analysis. When I say post-mortem analysis, to give you an example, like let's say we are part of an automobile company like Maruti. Okay, just take an example over here, and we are observing the sales data which is happening on a monthly basis, quarterly basis, and we have observed that the sales has actually gone down. So we can actually tell, hey, the sales has gone down, and we have observed the sales has gone down in these states. Probably in these states, you need to do something different. Maybe change the dealer, maybe maybe put some local ads. So what is this? This is like a post-mortem analysis, and that analysis is also powerful. Huh? It's not that that analysis doesn't make sense. That analysis also is used quite a lot in the industry. Okay, but when I say post-mortem analysis, there is events have already happened. You have captured data on those events, and then you are analyzing that data and presenting some insight. Okay, this is also something which you need to do as a data scientist, but that's typically what you do as a business intelligence guy or a business analyst. As a data scientist, you do something beyond that. You do that and also something beyond. You predict and give a insight for the future action, right? Like you might say, like, hey, if you're a telecom company like Vodafone and Airtel, you might say, like, hey, based on some behavior which I have analyzed in terms of calls, or in terms of complaints, or in terms of non-payment of bills, these are the customers who are likely to leave your network and port out and join some other network. Okay, and you, for each customer, you predict they're going to leave out, and you also may give a reason why you believe he's going to leave out. Okay, and because of the reason which you gave, the business decision maker, the marketing manager or the customer relationship manager may decide to intervene and call these people and try to understand their grievance or suggest them not to leave the network, right? So this is like more like a predictive insight, where you're predicting like these guys are going to leave your network, and I believe these are reasons why they're going to leave, and because of these reasons, I believe that you should take this decision. That is going to happen only because of machine learning. Okay, so machine learning is what differentiates a data scientist from a business analyst. Okay, so machine learning is super important, and as I mentioned, 70% of this course will be all about machine learning. 70% of this course, and machine learning is a lot of mathematics. And to begin with, okay, and apart from machine learning, of course, we do have modifications of machine learning, especially for unstructured data. Okay, we will talk about it as we'll talk about text predominantly, natural language processing. Okay, and we have text mining. Natural language processing is making machines understand the structure of language when there is an input given in text or speech to text. Machine understands what the user is actually kind of telling when it gives a natural language based input, right? So we'll also be covering those, but those are extensions of machine learning. That's what if you look at fundamentally. And some class of machine learning techniques, okay, one class of machine learning techniques which is neural networks. Okay, my writing is bad, but I'm just writing here neural networks. Okay, have gone some extensive research in the recent times, and neural networks are nothing but a very simple mathematical model of a nerve cell in our brain. Okay, there are mathematical models which represents a nerve cell in our brain. Okay, so recently we have, in recent times, in the last 10 years, I would say from 2012 is when the research started coming out. Neural networks have been the new architecture of neural networks which have come out. Okay, one is known as a convoluted neural net, CNN, and the other is known as a recursive neural net, RNN, the popular guys. Okay, and after these modified neural networks, modified architecture of neural networks which came out, we are able to mimic some of the actions of our human brain. Okay, we are just able to mimic some very basic actions of the human brain. Convoluted neural net is like typically right now I'm in my room and I'm presenting this, and as I'm presenting to you guys, the objects which I see is I see my modem, I see my computer, I see my television which I'm using as an external screen, I see a watch, I see my AC. So just in one image I'm able to identify all these objects. Let's say if I present the image of my room, I take a photograph of my room and present to a computer. Can the computer identify all these different objects? It cannot. Okay, but recently after convolution neural networks came, the computers are also able to identify with a very high level of accuracy. When presented in an image, they're able to identify the different objects in that image. That is one application, but of course there are many other applications where the convoluted neural net is mimicking the action of the visual cortex of the brain. Okay, visual cortex of the brain is that part of the brain which helps and which is connected to the eyes and helps you to understand what different images are there, right? So convolutional neural networks have been exceptionally good at helping in mimicking the function of the visual cortex, building some mathematical models for it. And recursive neural net has been has been instrumental in mimicking the actions of the auditory cortex. Okay, auditory cortex is that part of the brain which is connected to the ears, right? So these two classes of neural networks, okay, we are nowhere close to that part of AI where we have humanoid robots who will actually mimic the human action perfectly. We are no longer there yet, okay. We are at that stage where probably machine or humanoid robots can identify objects just like human beings can, and we are at that stage where humanoid robots can process language not to the complete extent like human beings, but to some limited extent, and give a response. Okay, so this has been possible with the modification of neural networks architecture called convoluted neural networks and recursive neural networks. Okay, and after this is done, these class of machine learning algorithms are known as AI. Okay, obviously there are other AI things like hidden Markov chains, reinforcement learning, so on and so forth. But these are the popular algorithms which made the word AI popular. But for all practical purposes, you are talking about data science and AI are synonyms. Okay, so AI or convolutional neural net, recursive neural net, this will be converted in a different course which we also are introducing, known as deep learning. Okay, so that's part of it. Okay, as I speak. Okay, Sudhir Kumar is saying, is that OpenCV you're talking, identifying objects in image? Yeah, OpenCV is one of the tools, but there are other tools as well. Okay, and you can even use tools like TensorFlow, which have a convoluted neural net architecture given over there, and you can use ImageNet data and identify that. So there are many tools out there which are based on similar kind of things. So Sudhir, this course, another thing which I want to tell Sudhir is, okay, I will not talk in terms of tools in this course. Okay, I will not say like, hey, after this course you will be very good in handling Azure ML. After this course you will be very good at handling OpenCV. No, I'm here to teach you the fundamentals. Okay, of how to, for you to understand which tool to use when and how to use those tools also. So after this course, you'll be able to use most of the tools which are out there in the market. Okay. So Sudhir, answer your question. Okay. So this is what it's all about. So you need to summarize as a data scientist. You need to develop some data acquisition skills. You need to develop some data pre-processing skills. You need to develop some data analysis skills. You need to have very good data visualization skills. You need to have an in-depth understanding of machine learning. You need to understand how to handle unstructured data, and we will be covering text to a large extent in this course. We'll do natural language processing and text mining, right? And then there is a class of machine learning algorithms which are mimicking the human brain, and these are specifically the ones which are popular are neural networks and their modified architectures like convoluted neural networks and recursive neural networks. After these algorithms came, this area is also being known as AI. Okay, but obviously that part of those algorithms will be covered in a different course called deep learning. Okay, so this is what you need to have and learn as a data scientist. Let me erase and draw some more. Okay, now those are the skill areas which you need to develop. Okay, Now coming to fundamental skills, what you need to develop as a data scientist. Okay, because looks like Mega was also asking about code, right? So fundamental skills which you need to develop, and obviously these fundamental skills lead to some of skills in the areas which I mentioned. Let me again draw a Venn diagram, and the first circle over here is nothing but your programming skills. I'm going to denote as PS. The second circle over here is nothing but your maths and stats. Let's call it math, because statistics is also part of math, so let's call it math. And your third circle over here is your business analysis. Let's call it BA, right? Now, if it is just programming and if it's just math, some people say it's machine learning. So this area is all machine learning. Some people say that, not me. And if you want to be a data scientist, you need to develop all these three skills over here. So it is this intersection area of all these three areas, which is data science. I'm just saying DS. So there is, and all three areas are equally important. And I cannot say, hey, it is this much percentage of math skills, it's this much amount of programming skills, it is this much amount of business analysis or business skills. Okay, I will not say that. But on a programming, if you want to be a data scientist, you should not be averse to the idea of programming, and you don't have to be on a scale of 1 to 10. If you don't have to be an 8 or a 9 in terms of your programming knowledge, but definitely you need to be maybe a 6 or a 7. Okay, and the programming tools which are popular for doing data science are R and Python. Okay, as part of this course, I'll be giving you definitely introduction to R and some amount of introduction to Python if you're doing the advanced course and there is text mining and natural language processing. But if you want to learn Python, I think there is another instructor who can actually take you in detail Python as well in the prime class ecosystem. So predominantly data scientists use these. And if I talk about any tools over here, it will all be programmatic tools or libraries in R and Python which we'll use as part of this course. And I think you can do all of that. Okay, you can do data acquisition, you can do data pre-processing, data visualization, data analysis, machine learning, deep learning, all through libraries in R and Python. So that's what we will use as part of this course. So both these languages are relatively very easy as compared to Java. That's my personal opinion, guys. Don't state me anywhere, but that's my personal opinion. These are relatively very easy languages as compared to Java. So picking it up should not be a problem. Second thing is you need to pick up your maths and stats skills, because whenever you're analyzing data, as I mentioned, like machine learning is going to be a large part of you as a data scientist. You will, when you're analyzing data and also when you're building machine learning algorithms, your mathematics knowledge is important. And when I say mathematics knowledge, you need to develop applied mathematical knowledge in linear algebra, okay, you need to develop good mathematical knowledge in probability and statistics, and required knowledge in maybe in coordinate geometry and calculus. Okay, and some amount of linear programming and optimization, coordinate geometry, and calculus, and some amount of optimization techniques like linear programming and genetic algorithm, some amount of optimization. So these are the stuff which you need to develop some good applied knowledge, applied mathematics knowledge. Anyway, in the meantime, Mega has asked a question. Sir, can we use e-views on this? I don't know what is e-views, Mega. Can you mean some way to present my presentation, something like that, e-views? Okay, I'm not aware what Mega is saying in terms of e-views. If anyone in the audience can help me, tell me on that. But it's an online course, so you can log in. Okay, it's like a software with built-in codes. Okay, Mega, I think it's like a software with built-in codes. Mega, here I do not recommend when you're doing this course. Okay, you use any uh, drag in and drag drop, any menu-driven techniques to actually do data science. I know there are quite a few out there, okay, where it's menu-driven techniques, where the code is already generated in the back end. You don't have to write the code. That does not work for you to be a data scientist. Trust me. That's my belief. As part of this course, you have to program. You will have to write the programs, and these are very fairly simple programs. And if you want to be a business analyst and see the data science ecosystem, right? It's a very important thing which Mega has pointed out over here. You don't have to be a data scientist all the time, right? If you want to be a data scientist, then what I've told applies. You need to not be averse to the idea of programming. You need to program, and you need not be an expert programmer. You have to be on a scale of 1 to 10, maybe somewhere at a 6. You need to be good in maths and stats, and you need to understand what's happening in algorithms, and that I think you need to be an 8 or a 9. Okay, so you can't hate mathematics and you can't hate programming if you want to be a data scientist. But in the data science ecosystem, it's not just data scientists who are actually earning a lot of money and thriving over there. There are a lot of other roles which you can take up. Like for example, you can be a project manager who is a conduit between the data scientist and the business manager. You can be someone like a glorified business analyst who's gathering the requirements of the data science project, communicating the same to the team, and enabling them, okay, in the delivery process. You could be someone who sells data science solutions. I'm actually doing that today. Most of the time, my job today in my startup, I spend a good amount of my time talking to customers, understanding the problems, and understanding what I need to solve to help them with the problems, and figuring out a data science solution for the same and selling the data science solution to them. Okay, that's what my job is. So I'm not really coding that much these days, right? So there are many such interesting roles which you can take up, and most of my colleagues who come from very senior management background with 15 years experience who have not coded, and I know they cannot start coding to that extent. I think roles like these are something which you can aim for and you can get in. So what Mega is suggesting over here is a tool where you don't have to code, where you can do some of the data science stuff using a tool like that. That's fine if you don't want to be a data scientist, but you want to be in these roles in this ecosystem. That's fine what she's suggesting. But if you want to be a data scientist without coding, you cannot. Okay, trust me, you cannot. So you have to do it. No other escape from that. Okay, Harika is asking a very interesting question. She says, R and Python help in clinical domain and to analyze huge data. Yes, Harika, R and Python do that, but I do have some very, in my past experience, 7 or 8 years earlier, I know in clinical data management and all, you use a tool called SAS. So it's just that clinical data management, you need to present reports in a particular format for the US Food and Drug Agency. And Food and Drug Agency, the reports which it requires, SAS has got a ready-made template for that. So SAS is actually very popular. So if you use R and Python, some of the templates you may have to redesign and do it. So people do not want to go to that headache. That's why SAS is popular in that area. But if you look at a domain outside the clinical data management, R and Python are actually much more popular than SAS today in today's world. I won't say that 6 or 7 years earlier, maybe in 2011, that was not the case. But today, R and Python are actually ruling the roost in terms of handling and analyzing huge amount of data, be it in any industry, be it the internet industry. You know, the internet industry is, the data generation is much more huge as compared to clinical data management. Be it retail industry, it's these two tools which are actually taking the lion's share. And even if you look at Azure ML, the Microsoft machine learning platform which they have launched, the underlying libraries are all in R. Okay, so Harika, hopefully I answered your question. And apart from programming skills and math skills, you need to develop a good amount of business analysis skills. Okay, so keep that in mind. So without the business knowledge, all what you do is fluff. People don't appreciate. And whatever you do, unless it translates into some revenue increasing insight, or unless it translates into some cost reduction insight, or unless it translates into some efficiency improvement, people are not bothered. So you should have the business analysis. You should know the area of the business analysis and how you use the data, what kind of algorithm to use, and how to present the insights. So that is super critical. So that's also something which you need to know. Okay. So if you go back to my healthcare example, which I spoke about, unless I knew about asthma as a disease, unless I knew that such data on pollution is present freely, I would not have been able to extend the data and present a good insight, right? So business analysis is also super critical. Coming to my course, as I mentioned, it's going to be heavy on machine learning. So 60 to 70% of my course is going to be on maths and stats. 20% will be on programming, maybe 10% on business analysis and business skills, because I'll give you the frameworks and how to ask the right questions. You should have a mathematical bent of a business bent of mind, and that's how my course will be divided into. Any questions before I go to the next slide? Okay, looks like no questions. If there are no questions, maybe one of you can confirm that there are no questions, because when I speak here, it's like a monologue and like a radio jockey. So unless I get response from you that you guys are understanding or appreciating what I say, I will not be able to, I will not feel so motivated to speak. Okay. Thank you, Harika. Thank you, Vipin, for giving your response. Let's move on to the next slide. Okay, data science. Okay, this is probably already I've explained this, but this is some definition which was there in the Wikipedia page, not so recent version. The goal is in extracting meaning from data and creating data products, and seeks to use all available and relevant data. That's why I said available and relevant data. Sometimes the relevant data may not be part of your internal organization. It could be some third-party data which you need to combine and use it, and then tell a story. Okay, or telling a story is nothing but generating insights that can be easily understood by non-practitioners. When I say non-practitioners, these are people who don't do much of data analysis. They might do, but not to the extent to which you will be doing as a data scientist. These are people who come from a non-tech background, non-programming background. These are people who take important decisions in the organization. These are people like CEO, the chief executive officer, the chief marketing officer, the chief operating officer, maybe the chief financial officer. Okay, so you need to present insights as a story which is they can relate to and they can take decisions. So this is what is the goal of a data science, and it's about not just creating simple reports. It could also be creating data products, and when I say data products, it might involve not just building a machine learning model or a predictive model. It can also involve in doing the necessary back-end engineering. It could also involve being exposed to, obviously that all that is not covered in this course, but you need to have maybe the DevOps operation. You should know what DevOps operations are being done and building something over here. Okay, Ajay Mantri is having a question. He says, I don't have any programming skills except HTML. That's fine, Ajay. Ajay, Megha, or anyone who are not so keen or who believe that they may not have good programming skills, that's fine. You can do this course. You can pick up the programming skills. As I mentioned, R and Python are very simple, and especially R is very simple. You can pick it up, but don't be averse to the idea of programming. That's all I'm saying. Okay. So even if you don't have any prior programming skills, that's fine, Ajay. You can still pick it up. Okay, let's move ahead. Yeah, this is something which I already explained. And okay, one thing I want to explain over here is what is machine learning all about. Okay, so any questions, or Ajay, you're okay with my answer? Okay, Megha is asking another question. Sir, I know the basics of R and Python. Are they enough? Megha, even if you don't know the basics of R and Python, you can still join this course. Any prior programming knowledge is not required for you to join this course, but you should not be against the idea of programming. That's all what I'm saying. Okay, so Megha, if you know R and Python, that's an added plus. So fine. Okay. Okay, so some of you who know what machine learning is, it could be a repetition, But let me tell you how machine learning is different from traditional programming. Like, let me again write something here. See, in traditional programming, what happens is there is data, okay, and as a programmer, you write a set of instructions, okay, and based on set of instructions which acts upon the data, the output is generated. And these set of instructions are written by human beings, that is us. To give you an example, let us take a very simple thing. You're logging in into some website, okay? So you have a, let's say, IRCTC website, Indian Railways website. Hopefully all of you guys have used it at some stage in your life. So you type in your username, you type in your password. The moment you type in your username and password, we have written a JavaScript code or a whatever, which takes that username and password entered by the user, goes to a backend system, validates whether this username and password are valid. The moment it knows it's valid, it allows the user to log into the system, which is nothing but the output. So here the data is username and password, and the JavaScript is nothing but a set of instructions which validates the username and password. If it is found to be genuine, the username and password, you allow him to log in, right? So that's how your traditional programming is all about. Okay, whether you code in JavaScript, Java, Python, doesn't matter, but essentially it's like that. In machine learning, it is different. So machine learning, what happens? There is again data, okay, and there are again a human being return set of instructions, okay, which tells what model to apply and stuff like that. Let's just see what it is. Instructions, and the output is not some action. Output is another program. Let me write it here. Output is another program which is actually a mathematical function. Mathematically, it's nothing but a function. Okay, and this program, it's called a machine learning model, but really speaking, it's a mathematical function. When you apply on a new data, this program, right now it's not human generated, but this new program is applied to this new data, you get an output. Okay, I'll give you an example of this. Right? Let us assume you're a retail banking manager and you want to understand which customers I need to call so that they accept a personal loan. I don't want to call everyone and waste my time where the customer is going to say no all the time. Okay, I want to call those customers who actually respond yes, and I'm able to improve my business. Right? So now you say like, hey, which customer should I call? So you go to the data science team and they say, hey, we'll build a machine learning model for you. And they build a machine learning model, and I say it's a mathematical function. They build actually a function. In fact, where y is nothing but a function of different x values. Okay, and what is y? Y can take the value 1 or 0. It's a variable which can only take two values, either 1 or 0. It takes the value of 1 when it believes that this customer is going to respond positively to the telephone campaign and say he wants to take a personal loan. and it takes the value of 0 when the customer is not going to respond positive to the loan campaign and says he's not interested in taking a personal loan. And what are X1, X2, X so on till Xn? X1 could be the savings account balance. X2 could be his credit card outstanding. X3 could be his monthly salary. X4 could be the kind of companies to which he belongs. Does he belong to a company like Infosys? Does he belong to some company, a startup? X5 could be, his age. So X6 could be something like his credit score, his CIBIL score. Okay. X8 could be probably his credit card monthly payment. One is credit card outstanding, another is monthly payment. So do you understand? So you're predicting whether someone should be called for a personal loan or not by building a mathematical function, and where this y is dependent on all these different x values, and these x values are which are the most logical relevant values which can actually influence a person to take a personal loan. It could be his account balance, it could be his income, it could be his credit card outstanding, and so on, right? So now what do we do in this kind of scenario? Here data could be customer data. We write a set of instructions. Output could be this function, okay? And this output is in the form of a program. And then when new data comes, this program is applied on this new data, and on each record, this new program tells you whether to call the customer or whether not to call the customer. The output is whether to call the customer or not to call the customer. At this stage, the output is nothing but this function. Here it's function. At this stage, it's action whether to call the customer or not call the customer. Are you guys clear on machine learning, or did anyone not understand this? I want a confirmation from the audience because I have told something which is profound, and Megha says yes, but what about the others? Harika says yes. Someone like Mr. Ajay Mantri, did you understand? Okay. Okay. Thank you guys for understanding this. So now you understand what machine learning is all about. It's all about building these functions. And let us move ahead. And maybe I'll come out of the slideshow mode because I don't need to show you all the slides over here. And of course, now the world is moving to a situation where people don't trust anyone's giving a strong opinion. People trust when you give an opinion on anything only if you talk in terms of data. Okay, so that's what is required. Let me see what are the other relevant stuff which I need to show you here. Yeah. Give me a minute, guys. Where is that slide? Oh, yeah. Let's go here. Of course, analyzing data and data science, there's nothing new about it. It's a very old thing. It's been happening in the industry for quite some time. Financial services has been doing it right from 1950s and 60s. And neural networks were conceptualized in the 1950s and 60s. Even automatic driverless cars, okay? Now you may think it's something which is of a recent thing, but if you just Google it out, Carnegie Mellon University, one of the leading universities in computer science, they actually built a driverless car in 1989. Okay, 1989. Mostly at that time, most of you may not be born, I think. If some of the younger audience were just doing the engineering or so, they built it in 1989. And 1989, they didn't have any of this high-end computers which we have now in terms of processing power, in terms of RAM, or in terms of hard disk capacity. And they built a very simple feed-forward neural network, okay, which could be run on a machine which has RAM in MBs, maybe a machine which has RAM of 8 MB or 4 MB. They were able to do it, right? And this car was able to drive on its own in the entire Carnegie Mellon University campus. I'm assuming it was a large campus. I've not been there, but a campus of maybe 1,000 acres or something, it was able to drive on its own, and it was even able to stop at signal pause inside the campus and drive. So there's nothing new about data science, machine learning, or whatever. Okay, the only thing which is new about this is maybe recently we came up with architectures like convoluted neural nets, CNNs and RNNs, which we found are very good in mimicking the action of the visual cortex or the auditory cortex. That could be new. But rest all is something very old, guys. So this is nothing like a rocket science or something cutting edge which you're learning right now. Okay, it's why it has become mainstream because of three things. Earlier, we never had so much of processing power, like CPUs and GPUs. High-end CPUs and GPUs are not available, but today they are available. Number one. Number two, RAM is much more cheap and easily accessible, high-end RAM. Okay. And number three is we are generating a lot of data. Okay, we are generating a lot of data not just within an organization, but also external to the organization. Right? There is so much of data which is getting generated in social media. There's so much of data which is generated in many other systems which are not internal to the organization, which probably you can utilize to generate some insights. So because of this, the concept of data science is sounding new, but in reality, it's something old. And today, maybe you have a buzzword like artificial intelligence, which is very popular out there. Back then in 2007, the buzzword was business analytics. Okay, the word data science, I came across it first in 2011. Okay, and now the buzzword is artificial intelligence. So these all are buzzwords which have taken different shape and forms, but really speaking, at a fundamental level, all mean one and the same. Okay, that's something which I want to tell you. So next is, obviously, I think I already mentioned this. There's a lot of data which is getting generated, so traditional BI will not make sense. You need to get into data science. Next, another important slide is this. As a data scientist, what do you do? Right? By this time, I've told you what are the areas you will work in as data scientist. The areas are data acquisition, data pre-processing, data analysis, data visualization, machine learning, maybe even handling unstructured data like text mining, natural language processing. Maybe in very rare instances, maybe you might even do deep learning. That's the areas where you will work in. And you also know what are the fundamental skills which you need to have if you want to be a data scientist. You need to have programming skills, you need to have maths and stats skills, and you need to have business skills. But what do you do? Typically, when you have a data science project given to you, what all things do you do? Okay, that's what this slide actually represents. So 30 to 40% of it, and this is my opinion, guys. Okay, there could be textbooks or there could be internet sources which may differ from this. This is my opinion. So 30 to 40% of the time you actually spend in acquiring data, cleaning data, preparing data. So when I say cleaning data, you could be filling in some missing values, you could be removing some erroneous records, you could be removing some outliers, you could be combining data from multiple sources. So that's going to be 30 to 40% of your time, okay, which is more like data wrangling. Okay, that is the buzzword now, data wrangling. And if you go to any data science interview, let's say you want to be a data scientist and you go interview for that position, 20 to 30% of your questions could come from this area, okay, on how you acquire, clean, and prepare data. After you do that, obviously you start analyzing the data, you start visualizing the data, and you start coming up with some hypothesis on what kind of model you want to build. You come up with a strategy. So data analysis, data visualization before building a model, and also strategy on how you present the insights. That is another 30%. Even they are broken 30 to 40%. Even they are broken down in two different levels like analysis and insights and strategizing and hypothesis framing. Combinedly, they are like 40%. Okay, so keep in mind you will be actually doing another 40% of that. So that takes close to around 70 to 80%. Okay, so in the balance 70 to 30%, let's assume it's 70%, you actually go ahead and build a model, a machine learning model if required. Okay, it's not that you always need to build a machine learning model to generate insights, but typically you do end up building a machine learning model wherever you want to give a predictive insight. So that machine learning model building and fine-tuning the machine learning model through iteratively is 25%. But if I want to break this further, this 25% further, the model building will just be 5 to 10%. 15 to 20% will actually be in evaluating the performance of the model and making changes to the model. So model building, which is the fancy stuff, which is the really cool stuff, is only 5 to 10% of your entire effort as a data scientist. Keep that in mind. After that, you present your insights It could be insights based on analysis. It could be insights based on a machine learning to the business decision makers so that they can make decisions. You don't make any decisions, but you present these insights. That is only around 5%. So understand this is how what you will be doing as a data scientist. So you will be playing around with data. You'll be combining data from multiple sources. You will be doing a lot of research on the business domain specific to which you are actually solving the problem. You'll be doing a lot of research on what kind of machine learning technique you need to choose. You will be doing a lot of research on how you will combine this data or what kind of data you want to combine with your existing data, right? And post that, you will, once you build the model and everything, you will have to do visualization at different stages. One is at an analysis stage, one is at your own understanding of the data, one is at your evaluating the performance of the machine learning model, and the third level of analysis is actually presenting this analysis and insights to the business user. So all this is actually going to be part of your role as a data scientist. Okay. Any questions, guys? Okay, if there are no questions, let me show you some other important slides. Okay, this is the source of this data is Indeed. And today, a data scientist who comes with no experience, who's just fresh out of college, he earns close to around 6,11,000. And I think this figure is realistic because recently, if you look at all these IT services companies like Infosys, TCS, Wipro, and Cognizant, traditionally in the last 15 or 20 years, they were always hiring freshers from colleges by paying them a salary of 30,000 per month, right? So which comes to annually around 3.6 lakhs. Recently, they have started paying freshers who understand machine learning or data science. They have started paying them 7.2 lakhs and putting them in a different program called the Booster program. And the salaries is bumped up from monthly from 30,000 to 60,000, which comes to 7,20,000. So if a fresh talent can easily get around that much, if he understands machine learning, data science, even if he's just coming out of campus, and I'm not talking about the IIT guys over here who could be earning much more than that. I'm talking about the non-IIT guys or whatever. This is where you can typically end up with that. And also, if you are having good amount of experience and you know data science and you have 10 plus years of experience, you can end up with salaries of 25 lakhs to 30 lakhs. Okay, so that is INR. I'm talking about 25 lakhs to 30 lakhs INR, and there are exceptions to that also. People with 12 years of experience and people who are working in maybe some e-commerce companies like e-commerce, like Flipkart, Amazon, or people who understand, who are working in some hardware and they're thinking hardware companies thinking of bringing in deep learning at a hardware level. I know those guys are even earning per year sitting in India, in Bangalore, in Hyderabad, or any of these locations, close to 1 crore. Okay, so there are data scientists who earn anywhere between 65 lakhs to 1 crore also. So I'm not saying just because you do this course, you will all end up with that kind of salaries, because it's dependent on your personal profile, your personal way how you pick up this and what you can do about it. But salaries of this range are possible, is all what I'm saying. And in this graph, you can see data science jobs are increasing exponentially. Big data jobs are also increasing, but data science is a much faster increase of jobs. Okay, Harika is saying, I have 6 years of experience now. After learning data science, will they consider my previous experience or I need to start as a fresher? Very good question. So Harika, if I can recollect your conversation, you have worked in the clinical data management side to a large extent. So if you play your cards well, if you position yourself in the healthcare vertical, and if you position yourself, I do believe that your previous experience will not go for a waste, but all companies may not consider your previous experience as relevant. Okay, let's say if you join some internet company like Amazon, they may not consider your previous work experience as relevant. Okay, but nevertheless, in internet companies like Amazon, if you prove you're a data scientist, you anyway start off with a salary of 12 to 14, 15 lakhs, even as someone with no prior experience, right? Amazon pays around that range. And if you go to a healthcare company like Novartis or anything, I'm sure they will consider that and they believe that you can add some value. And I don't know what salary level you are, you know it, keep it to yourself. But I think your previous experience will not go for a waste. Okay, did I answer your question, Harika? Okay. So that is about this. Let me show you some other relevant slides here. Yeah. Time is 12:15. I need to wind up another 10 minutes. So, any questions, guys? Any questions at this point? Okay. If there are no questions, again, I want to summarize what are your responsibilities as a data scientist. Obviously, you need to use um, the recent and the latest data mining techniques. You need to uh, extend your company's data with third-party data. Next, you need to process, clean, verify, and the integrator of data, which is all your data pre-processing. Fourth is you need to create some anomaly detection system or some early warning system, which is all about your machine learning models. And last, of which I did not cover much, which is what I want to cover. When you actually build a machine learning model, right? Like going back to the retail banking example, where I'm building a machine learning model where I want to predict whether a customer is going to respond positively to a loan campaign or negatively to a loan campaign, and I'm saying it's dependent on several factors. Those several factors could be something like a saving account balance, it could be something like a credit card outstanding, it could be the average monthly payment which he does through his credit card bill, it could be something like a salary he gets on a monthly basis, it could be the company which he belongs to, so on and so forth. So here, when you're building this function, let me just write it here. Y is equal to f of x, right? That is all machine learning is all about, right? Even deep learning is also all about that. Pradyum, I'll come back to your question. Just hold on. I think Prabandh, I'll come back to your question. You are actually building a model. Machine learning is all about building this function. So there could be several attributes, okay? In this retail banking example itself, if all of us sit down and list down, there could be 30 different attributes, okay? 30 different independent variables. And these X are also known as features. Okay, and you want to build this function. So when you're building this function, do you want to use all the 30 different features, or sometimes it could even be 1,000? When you talk about biological applications, when you're talking about DNA and microbiology applications, the number of independent attributes could even be 1,000. So among these 1,000 attributes, you want to build a machine learning model, you want to select a few of them. And how do you select a few of them? Okay, so there are techniques to do that. So that is also part of your responsibility as a data scientist. So if you go back to the banking example, there are 35 attributes. Assuming there are 35, I'm just taking a wild guess, and you want to use only 5 or 6 of them. So which 5 or 6 do you choose, right? So that's also your responsibility as a data scientist. Then you build the model and you optimize the model. Did you guys understand the selecting of features? All of you? Or is there anyone who did not understand this? Okay, Mega says yes, but Mega, I think you are a slightly an informed audience. I want someone else in the audience to tell that. Mr. Prabandh, did you understand what is selecting features is? There is silence over here. Okay, Harika, you did not understand? Yeah, there, Mr. Prabandh is all thinking of deep learning right now. He is not thinking about it. Some of you understood, some of you did not. So selecting features is whenever you're trying to build a machine learning model, those of you who are there from the beginning of the session, machine learning model is all about building a function, right? So when you build a function, there is a dependent variable and there are independent variables. So the dependent variable, we denote it as y. The independent variable, we denote it as x. The independent variables are typically called as features, or they could be known as attributes. In many cases, the independent variables will be several. Okay, if you just take the small retail banking example, here the dependent variable is a variable called y, which can take the value of 1 or 0, depending on the person's probability whether he responds positively to the loan campaign or negatively to the loan campaign. The independent attributes are maybe saving account balance, credit card outstanding, his monthly salary. Each one of them is independent attribute, right? I want to build a function which gives the value of y using these independent attributes. So when you have several attributes, you may want to choose only some of the attributes. And there's a reason for it, because the simpler the model, the better it is. Okay, and there are some applications. Okay, this is a banking example which I took so that all of us can relate to. There are some applications in biotech, and there are some applications maybe even in image processing, where the number of attributes could be 1,000. Okay, so from these 1,000 attributes, you would want to shortlist and decide which attributes to choose. That is also a very important skill set which you need to develop as a data scientist, which I am calling as selecting features. Okay, so hopefully Harika and Prabandh have got it now. And now going back to Prabandh's question, I don't know when Prabandh actually joined the class. Deep learning is an extension of machine learning. It's not that it is different from machine learning, first and foremost. In machine learning techniques, we have a technique called neural networks. Under neural networks, some new architectures have come, which is a subset of neural networks is 2 or 3 different techniques called convoluted neural networks and recursive neural networks. Convoluted neural networks mimics the action, has been found to be effective in mimicking the action of the visual cortex. A recursive neural network has been found to be effective in mimicking the action of an auditory cortex, which is that part of the brain is connected to the ear, and visual cortex is that part of the brain is connected to the eye. So activities like that, okay, come under deep learning, and the reason the word deep is coming over here is, I need to tell you a little bit of neural networks. The architecture of the neural network requires, because it's considered as layers and layers of nerve cells. So in deep learning, there are several layers of neurons or several layers of nerve cells, okay, mathematical equivalents of nerve cells. Hence the word deep, okay. And deep learning is all about several layers of the neural network, whereas simple neural network has either 1 or 2 intermediate layers, okay. So deep learning for all mathematically they're no different from machine learning. Prabandh, I'm answering your question, but from the way we fine tune these models, because they have several layers and layers of neurons as compared to simple neural network, we look at different optimizing, different techniques to handle them, and that's why it is taught as a different new course called deep learning. Okay, so hopefully Prabandh, I answered your question. Did I answer your question, Mr. Prabandh? And deep learning will be an extension to this course and taught as a separate course, and will not be covered in part of advanced or regular data science course or machine learning course, however these guys are positioning it as. Next, we have a question from Sudhir. He says, what's the level of statistics that we need to learn to crack the job? Yeah, you need to have a pretty in-depth knowledge of statistics. That's my opinion, Sudhir. And this course will definitely give you that in-depth knowledge of statistics. If you learn proactively for whatever we thought over here and we practiced it in some applications because there's a lot of data science competitions which keep happening. You can look at those and learn from it. If you have done that, and I don't see why you will not be able to crack an interview after learning the level of mathematics and statistics, which I'm sure which we'll cover in detail as part of this course. So Sudhir, did I answer your question? As I mentioned, this course is going to be 70 to 80% on mathematics. So that's what it's going to be like. Okay, let me erase and let me quickly take you through a small case and then conclude the class, because just to get me another flavor. Okay, what does the life cycle of a data scientist really involve? There's another thing. When I say life cycle of data scientist, I mean a data science project. Coming to data science projects, these are different from business intelligence or any reporting kind of a project or any application development which you guys have been exposed to. How they're different? One is they are low investment items from the organization's perspective. A data science project could be done by $100,000 to $300,000 or $400,000, whereas typically other IT applications are much more higher in investment, from the organization perspective. And this investment, I'm talking from the perspective of proving the value of the data science project. Proof of value. Okay, proof of value means, hey, this data science project is helping me in this business process and it's giving me some insight to generate revenue, minimize cost, or improve efficiency. So they are typically low ticket items, low investment ticket items, number one. Second is the team size which does the data science project is never large. Sometimes the data science project could be just done by one data scientist, and typically it could be done by 2 or 3. Maximum the team size could go up is 5 or 6. As a data scientist, you're more of an individual contributor, at least in the beginning of your career. Even later, if you are having people reporting to you, it will not be a large team of 10 or 20 people. It could be just 2 or 3 people who are reporting to you. So you're more like an individual contributor. Okay, so that's what you need to understand. So any data science project, not only is it low in investment, not only is it low in team size, it is low in terms of time taken to execute on it. A data science project could be sometimes 1 month or 1.5 month project. Maximum it can go is 6 months. And this I'm talking from the proof of concept stage. They're not very time consuming things. After proof of concept and deployment, it's not a major challenge. If you've proven the concept and you want to deploy it, deployment can happen again in a very short time frame of 2 or 3 months. And then you just keep continuously monitoring it. Okay, so that's how data science projects are different. So there is a data acquisition phase, which you guys have understood. There is a data preparation phase. After the data preparation phase, there is some amount of analysis, visualization. Based on analysis and visualization, you come up with some hypothesis on how you will build a model. So that analysis and visualization and hypothesis and coming up with a model is what I denoted hypothesis and modeling. So there could be a lot of iterations back and forth between data preparation and hypothesis and modeling. And after you build the model, you actually evaluate the performance of the model and you do some interpretation of the model. Okay, again, there is going to be a lot of back and forth. It's very iterative over here between hypothesis modeling and evaluation interpretation. And after the evaluation is done and people are okay with all the results shown, it can again, when it goes to a deployment, again there will be a lot of iterations. So even if you prove the proof of concept till the evaluation interpretation stage, the deployment can be probably you have taken 4 months to prove the concept. The deployment can be in the next 2 or 3 months, right? And again, there's a lot of iterative phase. And ultimately, after deployment, we monitor the performance of the model, whether it's doing really well or not. And if there is any changes that need to be made to the model, if it's performing poorly, we do that. One example of a model which you guys would have seen is your recommendation engines in Netflix or Amazon Prime. I'm talking about movies recommendation engine or TV show recommendation engine. If any of you have seen Netflix, you would have sometimes you'll be getting recommendation like this. Hey, you watched Bahubali 2, so hence you may like, and they give you a set of movies, right? That is happening through a model, a data science model, a machine learning model, right? In that case, there is a lot of data preparation which goes in. There is some hypothesis modeling which goes in. Maybe a collaborative filtering model is being built. Later, some evaluation of the collaborative filtering model has happened. And after the evaluation is done, people say deploy it. And the deployment could be done in a big data environment because Netflix and Amazon Prime, there are a lot of users who are actually accessing this system, this live system. And another point I want to make over here is when you are doing this model building phase, you don't need the entire data to do it. You need to do the model building only on a sample of data. Okay, so sample of data when you do it, even though your actual customer data could be, let's say, 50 GB, you just need 1 or 2 GBs of customer data to actually go ahead and build the model. So you don't need large amount of data to build a model, first and foremost. Okay, having said that, you may have to acquire or pull data from big data ecosystems. And sometimes when you're deploying the model, you have to deploy it in a big data ecosystem, like the examples I told, Netflix and Amazon. Okay, that's number one. And second thing is, very rarely the model building phase, you will play in the big data ecosystem. So that's why as part of this course, we're not getting into big data much because 90 or 95% of the time, you build a model on a sample of data. You don't have to need a big data ecosystem in which you actually build the model. So keep that in mind. And this entire phase is iterative in nature. Okay, I've taken a long monologue. Looks like there's some questions here. Any questions, guys, before I take Neha's question? Neha question. Okay, first question of Neha is, I'm a psychological honor student, and after that I've done one PGDM course in marketing specialization, and after that I have started working in NGO, and how this course will be useful for me as a successful career, and what about the placements? Also, I'm very new to programming. What will this course be beneficial for me? Okay, there are three questions. First, I'll take, will the course be beneficial for you? Yes, Neha, provided you pick up the skills of being a data scientist. Okay, and say pick up the skills. If you want to be a data scientist, first and foremost, you need to not be against the idea of programming, and you need to enjoy mathematics because you come from a psychology honors uh, background. So, can you pick up mathematics? That's something which you need to ask yourself. And this is not very complicated mathematics. These are mathematical concepts which probably are covered in class 10, 11, and 12 mathematics. So even if you're not done plus in class 11 and 12 mathematics, you can still pick it up, but you should not be against the concept of picking up mathematics, and you should not be against the concept of doing programming. That is if you want to be a data scientist. Now, after doing this course, it's not necessarily that you always be a data scientist. You can also become a business analyst who helps uh, size a data science project, or you can also be a person who actually talks to clients and keeps them informed on data science projects, or you can be a person who gathers information from the clients in terms of requirements, talks to the data scientist team, and formulates a plan on how a data science project needs to be executed. Okay, for all this you don't need to know much of programming. You need to have exposure to programming. You should know what's happening over there, but you don't need to code on a daily basis. Okay, so for you as a successful career, it's up to you for how you plan it. You can either get into a role as a pure play data scientist, or you can get into a role into some area which is around this ecosystem of data science. Okay, what I told you. You can actually be a business analyst because you come from a business background as well. And obviously, you also worked in NGO. So when you worked in NGO, I'm assuming that you developed a lot of people skills. Any people skills, any business skills also help you as a data scientist. But of course, when you get a job and you're trying a data science job, they may not be valued that much. But if you try jobs in the data science ecosystem of a salesperson or a project manager or a business analyst, they will still be valued. Okay, so being new to programming, you can still pick it up. Should not be a challenge, but you should have an aptitude to pick it up. Placements, I think for the next 5 or 6 years, there are a lot of opportunities in the data science ecosystem for you to place yourself. And guys, nothing against the ladies, but as a lady and as a your chances of getting a data science job is much better than a guy. Okay, this is my personal opinion. Okay, the reason I say that is because there are very few women in this field today, and people want, all the organizations, large organizations, they want to actually hire some women for as part of the data science teams. So if you are good and you can develop the skill set, your chances of getting a data science job definitely are a bit better than your counterparts in the male population. That's my personal opinion. And I know a person who comes from, okay, she came from economics and stats background, MSc, but she didn't have any programming expertise. And she picked up data science, and after picking it up, she was initially on a salary of 10 or 11 lakhs as a business analyst. She jumped to a large bank and she took up a salary of 27 lakhs. So opportunities are there. And course fee, Neha, I think you should check with the team over here. They'll be ready to tell you the course fee. But in terms of course duration, it is 3 to 4 months, and we should complete in that duration. And see, all of you can pick up data science on your own if you are determined and you have perseverant and you do research on a daily basis. It'll take you 1 year, 2 months to pick up this course. So we are as catalysts. We act as catalysts. Catalysts, as some of you are aware, are in chemistry. They are reactants which fasten the chemical reaction. So we fasten the process of learning for you. So we believe that you can pick up data science in 4 months. Post the 4 months you pick this up as part of this course, you can practice for 1 or 2 months, and you should be ready to take up interviews in a 6-month time frame, right? And of course, the opportunities are many, but cracking a data science interview is very, very hard. Let me tell you that. And this is a hard course. This course is not easy. Like for every 1 hour or 1 hour 30 minutes I teach, I expect you guys to put at least 3 hours of hard work. And especially those of you who come from a fresher background or who have a lot of time at your disposal, you guys should do this. Okay. Okay. So hopefully this answers your question, Neha. And Ajay has a very interesting question. He says, can we add some experience out of this course? Man, Ajay, you it's at your expense, man. You want to add some experience, you go add. But if someone calls me and says, hey, did Ajay work for you? I'll say no. I'll just say he has done this course. So adding experiences, creating work experience certificates, I do not encourage that at all. And neither can you use my name in adding any experience. Maybe you can check with Prime Classes if they are willing to give you some internship somewhere and post the internship, maybe you can add something. But frankly speaking, just after this course, I will not recommend you to just add some experience that you are a data scientist for the last 4 or 5 years. Okay. So Ajay, hopefully I answered your question as well. Okay, so did all of you understand this life cycle of a data science project and what it is all about, right? Okay, Megha is proactive. She's the one who's saying yes, yes, yes to everything. Others, I'm not sure. Okay, I'll conclude the session by 12:45 and I'm exceeding. Just quickly going through it. Let's consider problem statement. You're a real estate company. You want to understand the baseline price for all the apartments. Consider a real estate company which is actually selling apartments of several builders. And they come to a data scientist and he says, okay, I'll help you with this. So let us see all this quickly. I'll go quickly to the slide because we are short of time. And let us see what happens here. First is you need to acquire data. And when you acquire data from multiple sources, internal to the company and external to the company. Price, apartment name, number of bedrooms, floor number is internal to the company. Criminal rate per year. That is probably, if you look at the US context, it's coming from US census where they tell you what's the criminal rate of every area or every pin code area. Okay, so you can get that over there. Pollution level, again, if you look at the US context, you can get this data from Environmental Protection Agency, okay, which is third party data. Distance from nearby education institute, you can get this data from Google Places API. So again, third party data. So you have 3 columns of third party data. And also you can see some of the pollution level could be missing. The pollution level is missing because probably Environmental Protection Agency does not have a air quality meter or some meter to measure the pollution at that area. So the area the data is missing. So how do you handle that? You can handle it either through statistically or through business logic. The business logic is you go find out this area where this apartment in the second row is there. You find out what are the other apartments which have a value for pollution level and which are closest to it in terms of distance. And then you take an approximation over there, maybe an average of 3 closest apartments value and stuff like that. And you can also see another discrepancy over here, which is like some places ground floor is written as G and some places written as 0. You may have to bring it to a common value. So there is a lot of data prep like that, which involves combining data from multiple sources and also correcting for anomalies like this. The third one, education institute within 1 kilometer radius. Maybe the correction is it is too long a name, so you want to shorten it. And after doing this, you combine it into bring them into a JSON format or a CSV format, and you can do your analysis, and you can actually do their model building. And let's say you decided to do the model building, and after your analysis, which is visualization, finding out some summary statistics, finding correlation, finding independence and stuff like that, you decide that only I'll use 3 attributes to build a model, and the model, as I mentioned, is nothing but a function. Why over here, the dependent variable is the price, the independent variable is the bedrooms, criminal rate, and pollution, right? So you go ahead and build the model, and you can build a model in R or Python. Typically, that's what we use. If it's large, maybe Spark, and you build the model on a training data, on a data set, and a model, as I mentioned, is nothing but a program. And then you evaluate the performance of the model on a test data, which is new data, which has not been used in building the model. And you have some error metrics to measure the performance of the model. And if the error metrics and everything are good and the model is high on accuracy, which you say, and also the business users agree to it, you go ahead and deploy the model. The deployment can happen in a new environment, but calling an R program or a Python program in Java should not be a problem. Or sometimes you may have to recode it. Okay, we'll talk about that later. And after deploying the model, you actually may want to check the performance of the model. So you keep monitoring the performance of the model, whether it's giving the prices correctly or not. There could be some check in the way you do it. If it's not giving correctly, you go back to the drawing board and build the entire model again from scratch, or you may tweak the model by adding a new factor and see how accurate it is. So new factor will be distance from educational institution or maybe distance from a hospital. You can add that, and then again you redeploy it. So this is typically how the model is developed, trained, deployed, monitored, again trained, again deployed. It's a cyclical process. Okay. So I just taken through a use case. I think the other slides I've covered. I'll go to my last slide. Last was penultimate slides. Yeah, data science applications, several across industries. You guys are aware of it. And I don't need to say. And smart cities is a application of both Internet of Things and data science. Internet of Things because you are capturing data from several sensors which are there everywhere. Data science is models which are using the data captured from sensors everywhere, doing some analysis on that and generating insights and taking decisions in real time. Okay, so that is how smart cities applications are. And to conclude, what do you need to be a data scientist? You need your maths and stats skills. You need to pick up machine learning. You need to be very good in data visualization. You need to be very good in communicating, asking the right questions. You need to have a research bent of mind to understand the customer domain and to also understand data or to combine data. And lastly and foremostly, you should work in a team and actually present your insights. So, any questions, guys? Because this brings me to the end of the session. Any questions or anything which the Prime team wants me to add over here? Guys, I want some confirmation. Any questions or anything? If there are no questions, maybe you can type no questions. Or if you feel there are some observations you want to make, you can make those observations. It's very difficult an online class. Okay, Harika is asking of placements. Yeah, Harika, I think the Prime team does support in some way in the placements. They don't guarantee your placement as far as I know. But in case you are performing well in the course and you show a clean interest on doing something in the data science side, they may give you some internship and interview opportunities. Okay, but there's no guarantee on that. But I think they do have a team which works on that, but no guarantee on placements, but they can help you in that process. So Harika, hopefully I answered your question. Anyone else? I do see a lot of audience. Some of them are unattentive. Mr. Sudhir Kumar is unattentive. Let me see who all are unattentive. So guys, hopefully you have got what you're looking for. Is there anything which I didn't cover and which you felt I should have covered, or you have any question, please ask. Okay, Sudhir says no questions. Okay, good. If there are no questions, I would like to conclude this session from my end and leave this meeting. I don't know if the Prime team wants to give you some briefing. They can actually tell you what needs to be done. From my end, I'm actually exiting and leaving this training. Thank you guys and all the best. And I look forward to meeting some of you people. And thanks once again for taking your time on a Saturday and attending this session. Thank you.